Hi, this is Alex from devstories.eu. OpenAI and Swagger Ecosystem, Episode 13 of 19. REST is great for asking questions, but what happens when your API needs to be the one starting the conversation? Asynchronous APIs with webhooks handle this by pushing data the moment an event occurs, completely removing the need for constant polling. Historically, consumers had to write scripts that repeatedly checked your endpoints to see if a status had changed. This was inefficient for both their servers and yours. OpenAI 3.1 solved this limitation by introducing the Webhooks field right at the root of the OpenAI document. This addition brought first-class support for event-driven asynchronous communication into standard API specifications. Instead of solely documenting what a client sends to your server, the webhooks field allows you to document the exact reverse. You define the HTTP requests your platform will initiate and send out to the consumer's server. It is necessary to draw a sharp line between webhooks and callbacks, as the OpenAI specification handles them very differently. The distinction lies in how the destination URL is registered. Callbacks are triggered by a specific active API request. A client hits a subscription endpoint on your API and provides a target URL right there in the request payload. Because they are tied to an operation, callbacks are defined inside that specific operation object. Webhooks are registered out of band. A developer logs into a management dashboard, navigates to a settings page, and pastes their destination URL into a form. The API specification does not care how the URL was acquired. Because webhooks exist independently of any specific runtime API call, they are placed at the highest level of your OpenAI document, sitting right alongside your standard paths and components. To document a webhook, you open the root-level webhooks map. Every key inside this map is a simple string that names the event. For example, you might use the string payment.successful. The value attached to that key is a standard path item object. This is the exact same structure you use to define your normal REST endpoints. Inside that path item object, you declare the HTTP method your platform will use to deliver the event, which is almost always a post request. Here is the key insight. The perspective is entirely flipped, but the tools remain identical. You use standard schema objects to define the request body that your platform will send. In the payment.successful scenario, you specify that the payload will be a JSON object containing a unique payment ID, the exact amount charged, and a timestamp. You can also define headers, which is critical for webhooks because you usually need to document a cryptographic signature header so the consumer can verify the payload actually came from you. Finally, you document the responses you expect back from the consumer. You might state that your system expects a 200 OK status code within 3 seconds, otherwise your system will retry the delivery later. By standardizing this reverse API documentation, you give consumers everything they need to generate their own server code. They know exactly what payload to parse, what headers to validate, and what status codes to return. The root-level webhooks field shifts API design from simple request-response interactions to a fully documented event-driven architecture. That is all for this one. Thanks for listening and keep building.